Last time we had a video where we discussed how to design and simulate low pass, band pass, and high pass filter using Keysight ADS. In that design, we went through some calculations on how to get your discrete elements, that the values of the elements that were used for the design. So in the last video, which is also on YouTube, we had the design was titled "How to Design and Simulate Filters." That's low pass filter, high pass, and band pass filters using Keysight ADS. That's the same title on the YouTube page that you find the video on how to design and simulate. This is just an abstract, which is also the front page of the video. If you're interested, you can look up this video. You'll learn a lot on how to design filters. That video will mostly design Chevy design using various parameters. So in this video, we shall be continuing our design of filters. We'll be using today Keysight ADS DesignGuide to build low pass, high pass, and band pass filters. Actually, this is even much easier because it helps you avoid all the tedious work of doing calculations. All you just need to do is know your values, which for example, for the filters, what you need is just for example, if you have your cutoff frequency, you basically need to calculate what you want your beam, what they call beam width frequency will be. Beam width, for example, is at -3 dB. For example, you might say, okay, you want your band stop to be at, say, 40 dB, -40 dB. If you use the S21 scale, then what that means is at that dB, you want all your signals attenuated. That is, nothing will pass through. If you are designing a low pass filter, or if you are designing a high pass filter, that no signal for example, say you want attenuation at 20 gigahertz of 20 dB. That means at that frequency, from up to 20 dB, no signal will pass through. So for the filter design today, using a design guide, ADS DesignGuide, we'll just go through the step-by-step guide and take you through the design, analysis, and sensitivity simulation of a doubly terminated low pass Chebyshev filter. But actually, with the Keysight DesignGuide, you can design easily any type of filters you want. All you need to do, like I said, you just need those variables that you need to put in, and the design guide will do the work for you. You need for example, the pass band, the stop band. You need the attenuation band, also the stop band attenuation. So before you can use the design guide, you need to set up what we call the design environment. That you can find if you go to the schematic. You can find it. You can find it in the main menu as well. If you go to the main menu as on the screen, you see on the top right corner before help a design guide. So if you click on that design guide and you go to preference, then you see there are some things here that you need to click. So in the design guide menu, you choose either to use a selection dialog box or a use cascade menu. For me, I prefer the selection dialog box, and so you don't have to make compact your windows. You only use it when you need it. So also after when you click, you need to show the design guide menu as well. Then you can click OK. When you are setting it for the first time, you need to, when you click OK, you need to shut your design menu and restart it so that your settings will take effect. So after that, you need to open a workspace. A workspace is already open, and then we need to start a new schematic. You can decide to label it or change the name. You change it to a suitable name that will match what you're doing. So for this, I'll just leave it as cell 1, and I have a new schematic created. Just to point out something, these are the values I'll be using for my high pass, low pass, high pass, and band pass filters for the design guide. So if we come, so here we can start our design. So what we do after opening the new schematic, we need to open the design guide, which we can find there. So if you click on this, you see all the various models or the design guide that are included in this ADS 2020. Sometimes the design guide might not be there, so you have to like install it yourself. And that's a tutorial for another day, how to do that. But just in case you have your design guide already installed, what you need to do, we are designing filter today. So when you click on filter, so here you have a new window open. Here you have on the window various menu. You have a filter control window, impedance matching, Smith chart, filter design. If you want to view or study the documentation, you can click it there. It's a PDF file. It's an help file. Then you have information about the design guide. So for here, you click on the filter control window. This will open the filter guide control window. So in this particular instance, it gives you the first page here. You have different information here. You have the file. If you want to exit design guide or reset dialog information, then tools tells you there are some actions it can perform automatically, and then we have the view palette. So in this case, because we want to design a filter, we need to add a component palette. So when you click on component palette, you see the component palette shown on the left side. Also, clicking this one too will open that same palette. So for what we are doing now, we have about 8 different filter design. This first one here, DT, is a low pass filter design. What they call a double terminated. This is a high pass filter design, double terminated. And this one is a band pass, and this is a band stop. We have a single terminated low pass, single terminated high pass, single terminated band pass, and single terminated band stop. So, but for our design, we'll start first with the low pass filter design. So if you click on this and you add, but then before you add, there is something that you can do. If you click if you click on just before you add it, insert, and you click component, it gives you an opportunity to change the orientation of your the smart component you are adding. You can even turn it upside down, turn it left, right, left or down, or you can do that as well without button over there. So we just leave this and we put our smart device, smart component in. So we have here our smart component. I have my Yeah, we have our smart component. So what we need to do now is this is a smart component. This one is a low pass filter smart component. So if you double click on this, it gives you the parameters that you have to enter for your design. For example, we have for this filter we have various parameters here. We have the F the FP, which is the passband corner frequency. We have the FS, which is the stop band edge frequency. We have the passband attenuation variable and the stop band attenuation. What basically means is if we go back to our circuit, we are working with the low pass filter. So what basically this one is telling F1 now is telling you, for example, if we pick to have our passband attenuation at 3 dB, it basically means that if we pick at 3 dB point here, we should have a passband. First, let's put in our values, then you understand better what I'm trying to say. So if we put here FS FP of 27, FS 32, AP3, and we use AS of 40. So we leave the other one. This one will be done automatically. We'll explain later. So what basically happens now is if we use this as our design guide, it basically means that at AP attenuation passband of 3 dB, our FP will be 27.5. So that's at that point, that's what we're telling our design that we want to have. And for example, for the 32 dB, we want that at a frequency of 32 hertz. At frequency of 32 hertz, we should have a stop band of at least 20 dB. We use 20 dB stop band of 20. So that means at 32 dB, at 32 frequency, our S21 should be at least 20 dB minus 20 dB or more. So that's what our design criteria now. We are giving the design guide what it should be designed for us. So if we click OK, and we have the circuit here. All we need to do now, we go back to our design guide, design guide, and come. If you watch here, we have this is our schematic display here, but our smart component is not here yet. So if you go to smart component, you now click there, you select the smart component. So this is automatically they are linked and connected now. So if we have this, we can now go next to filter design. You see that all the values we put in here, they are all reflected here. But here, there's something we can change. You can still change all the values here. That's the beauty of the filter design of the design guide. If you here, the response type here is being displayed as maximal flat. Actually, we can select any design guide, any type of filter we want. Everything when you calculate, it do, for example, the order calculation by itself, and that's it. So having we have a doubly terminated impedance. The source is 50 ohm and the load is 50 ohm, and we're using a parallel element design. So we have our 3 dB and the 20 dB we have there, and we have our order, which is 6. Going to use a 6 element for the design. So if you click when you satisfy with this, you click on the design. Yeah, you see it's completed the design now. So having done that, your design is completed. What basically happened if you go to push in here, because it showed the design before it went back because we're using with the smart component. Just to see the design again, if you go to push up, you click on it first and you go to push up, then it will now give you, you see the design again. You see the beauty of design guide. It does everything for you, the circuit, everything. It does the values and put them in. So to go back now, we can go to pop out and go back to our design guide. So having done this, we can just go, because it's like complete now. We can now go to simulation assistant and input our values which we want to use to simulate our design. So in this case now, since we had a 32, our frequency between 32 and 27, we can just say, okay, let's start our simulation from 15, say up to 35, and leave this the way they are, and make sure this automatic display result is clicked. And when you simulate, it's still simulating. So having simulated now, we have a nice output here. We can see that if we just make this largest, we have a nice plot of our design guide. This is the S11 plot. We have on this graph, on this plot, two graphs. The dark one, the black one, is the black one is our specification. You remember we specified for 3 dB, which is somewhere. We specified that at what was our frequency? At 27.5, we have a dB of 3. So if we go 27.5, a dB of 3 should be somewhere there. So, and our plot shows that if you look here, we have at 15. Yeah, and at 20 dB, which is our design guide, you see that at 32 we have, because we specified that at 32 we should have at least 20 dB, and at 32 gigahertz here we have over 20 dB. So which means it satisfies the condition And on the 3 dB scale as well, we have that at 27.75 it should give us 3 dB, and here we have at 27 point, but our 3 dB is here, so which is more than 27. Let's just put in this. It's got at 27.75 we have 2.9, so which is which meets our specification. So that's it for the low pass. We'll now go on to design the high pass. It's exactly the same principle, but the values you need to change. But in order for you to be able to proceed to the high pass, we need to exit this, otherwise ADS somehow does not allow you to have a particular design guide open and run another one. So what we do, we need to close this, and because you cannot find it now, I will close that. So we move on to the high pass. I will create, just a reminder, the schematic we designed before, this circuit we designed before, we only need the design guide to do it once. We don't need, if we want to use it, we don't need the design guide anymore. But the only condition maybe we might need design guide if we want to maybe change parameters and analyze it, then we can use design guide again to analyze it. For example, if we just put in our we can run this simulation independently, because we don't need design guides. It's already our circuit. We see we can use this circuit in any other design that we need. We don't need the design guide anymore, unless you want to reanalyze and maybe change parameters and reanalyze it. So if we put in our simulation conditions 115 35, right, and we simulate this, then I will put in our rectangular plot. Say we have S11 and S21, and add a dB and click OK. See, this is what we have. We have the ripple, and this is our S11, the input. So basically, we can just use the design without the design guide anymore. So we'll conclude this now and move on to the high pass filter. So we open a new schematic now for the high pass filter design. Like we explained before too, we use this high pass, this value. Like before, we have our 3 dB point here, and our 3D point we design it out for 24.5 gig, and we're doing our pass band to be at least 20 dB in 20 gigahertz frequency. So we now go again to our design guide, filter design guide, filter control window, and we select here from here we can get our smart component. And here we're doing here, this is the pass, the high pass now. So if we add that, I will add our design values just like before. These values here. So we have fs of 20 gigahertz, fp 24.5. Then we're using 3 and 20 dB again. So if we run, say this okay now, I will open again our design guide. You see, like here we need to select this now, the high pass DA, L is automatic naming from ADS, the DA LC high pass to the one. So like before, we go back to the filter assistant to check and see if it's what we want. The values, because if you change any values here, for example, let's put this at maybe 10, everything change. So it depends on what design you want. You just select value and you can monitor your design here. Then we're doing too the shape. This is what's going to give us. So here we have order 5, which basically, like I explained before, means it's going to use 5 elements for this design. If we change to maximally flat, it uses 12 elements. So if you go for bezier, it uses 9 elements, and you go for Gaussian, it uses same 9. So sometimes it makes sense to go for the least element. In this case, we have a 5 element, which are the 5. So if we click on the design, hopefully it should be without problem. So it means the design is complete. So like now, if you go to push in again, you need to click the component first. Then you can see nice and easy a 5 component high pass filter here. So we'll now go back to our design and continue here. So after we finish, we're satisfied with the design, we'll now go to simulation assistant and click and select our value. Like before, because we're using almost the same value with the low pass filter, we start from 15 to 35. You can leave the step, this one too. So we'll always make sure the automatic display is clicked, and then you simulate. So simulation is finished now, and our results, I don't know, it always display at the back for some reason. So this is our result now. As you can see, we have our high pass filter, because we start at 15. Here we have our this a little bit. Let's this start exactly the way we ask it to start. So we can just change our plot options here. So we'll have a nice graph for the x-axis. For the y-axis, we just say up to 50, from 0, a step of 10. And for the x-axis, we want from 15. We want from 15. So which is 1.5. 15 E9, which is 15 gig up to 35, and we'll click OK. So now have our so for our high pass filter now, we're having our design, our specification was to have at 20 gigahertz at least minimum minus 20 dB. So we can see that here at that frequency we have over 20 dB, which satisfies our criteria. And for the other frequency band, we have 24.5, which should be somewhere around here. You see that it gives us more value as compared to our design guide. So which means our design was a successful one. So we now conclude like for the just like for the low pass. Yeah, just like for the low pass, we can just use this circuit for our simulation as well. All we need to do is just complete the circuit by adding terminator. Like I explained before, you can use this circuit independently or with other circuits, or add it to other circuits. Without, you don't need to use the design guide again. The design guide only if you want to use it, maybe to resynthesize your value, or maybe when you change values or you want to change from one design type to another, then you need to go back to use the design guide again to update your design. Otherwise, if you don't change anything or if you don't need to do anything, so if we just put our simulation conditions again, from 15 to 35 in step 0.01, I will simulate this. What our rectangular plot, adding x11 and x21, and we should have our nice curve. Because there we have at there 20 dB, 20 gigahertz frequency, we have about 21.55, which satisfies the condition. So now close this and move on. This is completed. So we now do for the bandpass filter is basically the same principle. What basically changes is the values, because now you are designing for two conditions. So we'll go through that again. Just like before, you have your new schematic. You click on design guide, your filters, and control window. Here you go to components and you click. This is the third one is the doubly terminated bandpass filter. So like before, we entered values in just like I did here. The values for this are more because we are designing for two different cutoffs now, two different pass band, and we have the lower stop band, which is the FS1, and here we are using for our design 20 gig. For the second one, which is the lower pass band, we are using 24.5 gigahertz, and for the upper stop band, we'll be using 27.5 and 32 for the upper stop band. Then the upper stop band corner frequency, and now this is the upper stop band 32 dB. So we're operating with 3 dB, but this time around we'll change the stop band attenuation to 40 dB. So we leave every other one. We have some conditions here. This NO we leave at 0. The design guide automatically do the calculation and compute that for us. I showed you before. Then we have the response type. These are just default. We'll change this in the design guide. And we'll have the minimum inductance. Then we'll have the arrow I. The arrow G and the arrow I is the input and output termination. Is like the source and load impedance, and then we have mass realization of that. So if you click on apply, okay, I will now go to our design guide. We select here the passband component. This is very big here because then we'll go back again to our filter design. You can see that it's giving us already some design view shot, but for this it's giving using maximally flat filter design, but we can use any type of filter design like I explained before. We have the Bessel, Thompson, the Gaussian, different type. So I only like using Chevy. So if we put this now, I will click on design. So design is done now. So if we go back here now, we select the element and push in. Then we'll now see our nice and easy passband design. It's a three element here. It's a three element each. 3 for the low pass, 3 for the high pass. So that's why it's a 3-element design. So have we done that now? We cannot do a simulation, and we go here. We have filter assistant. The next one is simulation assistant. We click on this, then we change our values here again, and I start from like 15, and because we are basically operating the 25, 26, 27 gigahertz branch. So say from 15 to 35, and this is okay, and this one is okay. And when we click on simulate, so simulation is nice and done now. So we can see that we have here our nice and beautiful Chevy bandpass filter. As you can see, we have for the 3 dB to 24.5. So if you trace this 24.5, your 3 dB will be around there. And for the 20, we specify that at 20 gigahertz, we should have a minimum at least minus 40 dB. But at 20 gigahertz here, we have about over 50 dB, minus 50 dB, S21. And on this side too, we specified at 32 gigahertz. So at 32 gigahertz, we are somewhere here. So which is over 44 dB. So at the end, you see that this design guide has beautifully done our design for us. If, for example, we're not satisfied with that, we can always go back to our design guide, go to filter assistant. Then let's change. For example, you say you don't want the Chevy shape, you opt for the Bessel one. All you just need to have you change anything here, you redraw, and then you design the system again so that you can alter this. So you see that when that is done, you're satisfied with that, just click done, then push back, and you now go to simulation and simulate this, and let's see if there will be any difference as compared to the previous one. Okay, all done now. Finish. So if we look at our graph, we see that it's changed now. In the previous one, we had like a ripple, and our plot is quite different. So, but the thing is, at 20 dB, now, at our 20 from this design, so it means this base design, we need to try to optimize it or change parameters again because it does not meet our design specification. Because we gave that 20 gigahertz, we should have at least 40, but here we're having about 30, 32 or about 30, but it's not up to 40 our design. On this side too is same thing. So at 32 it's giving us about 26 dB. So which means this particular design does not meet our design specification. So we can still go back, and anyhow you can do it as many times as you want. You go back to filter assistant and change whatever you want. You can say, okay, let's go to order 4. When you change order 4 or order 5, number of elements, you see that every time you make changes, you move. So if you redesign this, you see that the number of elements here now increase. You have 5 for the low pass and 5 for the high pass. So if you go now to simulate this, and click done, and you go and simulate this, you can nicely again view the when it's finished. I will view again. Done. You now view. You see, it still move, but it's not on this side at 32. It does not satisfy, but this one at 20 is satisfied on this side, but at 32 gigahertz is a little bit short. So obviously we can continue to add elements or change any values until in a way it's like optimization. You continue to change values until your specification is met. So basically that's it about antenna. That's it for filter design using Keysight ADS Design Guide. I hope you enjoy this, and thank you.